Hey, welcome back. Today we're looking at 4.5 graph of rational functions. And what we're going to be doing is we're just going to be analyzing the graph. So yeah, we're going to pretty much be doing all the stuff that we've been doing. We're going to throw in a couple more things like finding the zeros and intercepts. And we're going to check the graph. Okay, so we want to analyze this. So step one, if we refer to this chart here, is we're going to find asymptotes and holes. So what we're going to do is we're going to take this bottom part and factor it a little bit. So I know that's a difference of squares because I have a perfect square here, a perfect square there, and a subtraction. So it's going to be x plus 2, x minus 2. Okay, so I have asymptotes, right? There's nothing. Well, we don't have to write the whole word out. That's kind of too much. So vertical asymptotes. Okay, so our vertical asymptotes come from the bottom. So we have x plus 2. So what makes that 0? That would be negative 2. We need to say x equals negative 2. And then what minus 2 equals 0? That would be a 2. So we have two vertical asymptotes for this case. The horizontal asymptotes, if we refer back to this one, the top degree is 1. The bottom degree is 2. So if the top is smaller than the bottom, we have a horizontal asymptote at y equals 0. Okay. Let's change colors here. Step 2 from the previous one is we're going to find all our intercepts, right? So let's do that. So y equals, I should say y equals. So what we're going to do is we're going to set it equal to 0. And then solve, right? So that will tell us our x-intercepts. Okay, so the easier way to do this is, if you think about it, when we're finding a 0, if our whole function is equal to 0, then the numerator is equal to 0. It doesn't matter what the bottom is, but then you'll see algebraically as well what happens here. So x squared minus 4, x squared minus 4, I didn't leave enough room. But this cancels, right? That's the whole reason we did that, to get x by itself, this x minus 1. But 0 times this whole thing is also still 0. So it kind of reinforces the fact that if we're having a rational function and it's equal to 0, we just have to worry about the numerator. What makes the numerator 0? That's going to be 1. Right? So we have a 0, or our x-intercept at 1. Okay, so for our y-intercept, remember that's going to be the f of 0, right? So f of 0. So we're going to do 0 minus 1 over 0 squared minus 4. So that's negative 1 over negative 4, which is positive 1/4. Okay, and then it says checkpoints, but at this point, let's just see that our graph is correct. So x minus 1 over x squared minus 4. X minus 1 to x minus 1 over x squared minus 4. And let's just check the points. Since we have Desmos, there's no reason really to graph it out. But it says that we have 0 at 1. Correct, right? That's what we said from here. X-intercept at 1. A y-intercept at 1/4. Yep, 0.25 is 1/4. And then it also says we have a horizontal asymptote at 0 here. Okay, so let's check our horizontal asymptote. Whoops. And if it helps you, you guys can draw these asymptotes in. So if I say y equals 0. Okay, we can see that this gets closer and closer to that line. The green gets ever and ever closer to the purple line. And then also we have two asymptotes. So we're going to say x equals 2. And then x equals negative 2. Equals negative 2. Okay, and then if we pull this out, hide this, you can see that this graph gets ever closer to those two asymptotes, the red and the black ones, but never quite crosses through it. So we know that we did the analysis correctly. All right, let's go back and actually let's erase this stuff, clear it out, so we're ready for the next one. Okay, so we're going to analyze x squared minus 1 divided by x. So first thing we're going to do is start with asymptotes. Vertical asymptote. What makes the denominator 0? That's 0, right? So we're going to say, actually we should say x equals 0, right? For doing this the proper way. X equals 0. Horizontal asymptote. Well, the top degree is 2, the bottom degree is 1, so it's bigger. So we know that this one is not going to have a horizontal asymptote. Right, this is step 1, doing the asymptotes. Step 2, we're going to find our intercepts. So our x-intercept, we said, is the top, right? So what makes that 0? It's going to be x squared minus 1 equals 0 plus 1. And then square root. So we have positive and negative 1 for our zeros on top, right? Because 1 squared minus 1 is 0. Negative 1 squared is 1. Minus 1 is 0. Okay, so these are our x-intercepts. And then we can find our y-intercept. We said that's f of 0, right? So we're just going to say 0 squared minus 1 over 0. Oh wait, but we have an asymptote at 0, right? So this is undefined. And therefore we have no y-intercept. Okay, and then let's check our graph here. X squared minus 1 over x. X squared minus 1. It's not what I wanted to do. Put it in parentheses. X squared minus 1 divided by x. Okay, so you notice that when we're talking about our end behavior, it's increasing towards the right and decreasing towards the left. So it's not going towards a specific value, and that's why we say we don't have a horizontal asymptote. But what we do have here is we have a vertical asymptote, right? We said that our vertical asymptote is x equals 0. So you notice that that's the line that the graph doesn't cross in green. And we also said, what did we say here? There's no y-intercept. So yes, notice that because they never actually cross the y-axis, that there's no y-intercept. So that's an example of what our graph should look like from our analysis. Okay, so good job on that one. Let's do one last one. Okay, this one looks like we're going to have to factor a little bit, but that's fine. All right, so the first thing we're going to do is find our asymptotes, but first we're going to factor it so it's easier. On the top, I'm going to factor this in my head. So we're looking at 2 times 2, which is 4. What multiplies to get 4 and adds to get 1? That's going to be negative 1 times negative 4. So I need to make sure that I put my factors here. So negative 2 times our positive 2 is going to give us a negative 4 here. And then negative 1 times x is going to give us our negative 1 there. And that's how we get our negative 4 and negative 1 to add to get 5. The bottom, again, is a difference of squares. So x plus 2, x minus 2. Oh, wait, look. Those are going to cancel. So we said that we're going to talk about what happens if we have a hole later. There is a hole there. Okay, so we're just concerned with the 2x minus 1 over x plus 2. So we have a vertical asymptote. right? Wherever the bottom's undefined. So at x equals -2, we should have a vertical asymptote. Horizontal asymptote, what we have here is we have the same degree, right? We have x to the first on the top, x to the first on the bottom. So what we're going to do is we're going to take our ratio of our leading terms. So for 2x, it's 2 over, be careful you don't put a 0 there, right? Because there's actually technically a 1 in front of our x plus 2. So 2 over 1, which is 2. So y equals 2. All right, and then we're going to find our intercepts, right? So let's go ahead and do that. So for our x-intercept, we said whenever the top is 0, right? So 2x minus 1 equals 0. We're going to use our algebra here. And we get that x equals 1/2. That's our 0. And then for our y-intercept, we're going to do f of 0, right? So f of 0, which is 2 times 0 minus 1 over 0 plus 2. 2 times 0 is 0 minus 1 is -1 over 2. Okay, so let's just check that we got all our stuff here. Vertical asymptote is -2. X equals -2. Horizontal asymptote, y equals 2. We have 1 x-intercept, or 0, 1/2. And then we have a y-intercept of -1/2. So let's put this all together. 2x squared minus 5 plus 2. 2x squared minus 5x plus 2 divided by x squared minus 4. All right, so let's check our intercepts. Okay, our x-intercept as 1/2, our y-intercept at -1/2, perfect. We should also have, looking back here, a vertical asymptote at -2. Let's check. So I'm going to put in x equals -2. Yep, that checks out. And then we have a horizontal asymptote at +2. So, wait, not an expression. It's the wrong one. Oh yeah, that is an expression. Y equals 2. And as you can see here, if we keep pulling this out, that black graph line gets ever and ever closer to that green asymptote line. So it shows our end behavior. So everything checks out. All right, so that's it for today. So what you guys are going to be doing mainly is you're going to be finding the two asymptotes, vertical